Today, I'm Keanu Magsabol and I'm going to demonstrate to you on how to design the beam of a single reinforced rectangular beam of a two-story apartment house. According to the owner, this apartment was built on the late 1980s, where timbers are still used in building some parts of the main structure. In here, we can see that the walls were built from reinforced concrete, as well as its girders. The girders are casted along the apartment, which acts as the carrier of the wooden joists, and as well as the reinforced concrete walls of the second floor. However, the second floor floorings were not built from concrete slabs. The floorings are actually built from wood planks, which then are positioned on top of the joists. The joists are 2 inches in width, 6 inches in height, and have a span of 12 feet long, which secondarily holds the floorings of the second floor. Over 30 years, the structure of the apartment gives signs of failure, especially the wood floorings and the joists. The floorings and joists are being eaten up by the termites, which made the structural integrity of the apartment weak. The floors are screeching when being stepped on, and there are areas where holes in the surfaces are visible, which made the owner decide to renovate the apartment. So the owner made a plan of putting a reinforced concrete beam in place of some of the joists in order to strengthen the flooring of the second floor. Now, let me demonstrate to you the calculations that is used in the design of the beam, or the number of reinforcements appropriate that is to be constructed in this two-story apartment house. Here, we are given the properties of the concrete and steel, as well as the service loads with accordance to the NSCP. It is then required for us to determine the number of 16mm diameter rebars that is appropriate on the specifications given. According to NSCP 2015 for the load factors, we'll use a 1.2 load factor for the dead load and a 1.6 load factor for the live load. And then we'll be able to calculate the ultimate uniform load W sub U of the beam. Next is we calculate the ultimate factored moment M sub U of the simple beam, and then followed by the coefficient of resistance R sub U. Using the coefficient of resistance, we will now calculate the rho required for the design of the beam. After getting the rho required, we will check if it passed on the NSCP standards using the rho min and the rho max. The rho required must be greater than or equal to the rho minimum and must be less than or equal to the rho maximum. And since our rho required is in between the rho min and rho max, our rho required is okay. Using the rho required, we will now calculate the total area of reinforcement A sub S. The A sub S will then give us the number of 16mm rebar that is to be used for the beam.
Before finalizing, we have to check first the detailing of the design by checking the spacing of the reinforcements to each other. The minimum requirement on the reinforcement spacing based on the NSCP is 25 millimeters. And since our spacing is greater than 25 millimeters, therefore our design is okay.
In summary, this apartment is to be renovated, and some of it are the floor joists that will be converted into a singly reinforced rectangular beam in order to strengthen the structural integrity of this apartment. So thank you for watching, and I hope you learned something from this short report.